Before we start the video, subscribe, leave a like, and let's get started. So what are generators? A generator is a function that can be paused and resumed during its execution. In other words, our function can stop and, at our request, continue executing. At the same time, they return an object that can be iterated over. Unlike lists, they are lazy, so they only process the current element when requested. This way, they use memory much more efficiently when working with large datasets. So when we work with a large dataset, if we have a big list, we can use a generator to retrieve our data sequentially. Generators have two keywords, either and next. Iter allows us to iterate over our generator in a loop, and next returns our next value. Let's look at an example to see how this works. So let's write our generator function. A generator function uses the keyword yield. Let's say, for example, there will be yield1 and also yield2. Let's write let's run data func, or actually not func, but rather more specifically gen. And with the help of next, we'll return the next value. We'll put data here and call it several times, in our case twice. Let's write print index.py. We see 1 and 2. If we try to output a third value, we'll see that it raises a stop iteration. We can also write a loop here, for example, for I in range 10, and sequentially output our 10 values. We see 0, 1, 2. We can also write a loop and pass the generator here. For example, when we use a generator expression such as gen and then print out the variable I within a loop, we are able to observe each element as it is produced. This allows us to see our entire sequence step by step as it is generated and displayed in the output, which helps us understand how the generator works in practice. So by using a loop, we are implicitly calling our next method. In other words, a generator allows us to work with large amounts of data. It does this by letting us retrieve values one at a time. It's also important to look at a construct like yield from. It's not used often, but sometimes you need to work with it. For example, let's say we need to call one generator from another generator. How do we do that? The yield from construct allows us to conveniently call another generator from within our main generator function. What does that look like? For example, let's call Gentwo and use the yield from construct, and we'll write our regular generator. We'll write data equals Gentwo, and we'll carefully retrieve our values one by one, step by step. Now, let's print the next set of data. We see our value. Good. Besides generators, Python also has coroutines. What are coroutines? A coroutine is, first and foremost, a generator that accepts some value. Not every generator is a coroutine, but every coroutine is a generator. Let's see what that looks like now. Suppose we have a generator. We'll keep the loop as well. And we'll be receiving some value. But before that, we actually need to get some value. Let's say it will be some number. And we'll receive this number using yield. That is, when we pass our value into our coroutine, our value will end up right here. Next, we'll output number with yield and multiply it. It's a rather abstract example, but soon it will become more or less clear how this works. Again, let's output data, gen. Next, we'll call next on data, and then we'll use send on data, let's say, with the value 2. And we'll print it to the console. We check the console and see our 2. So first of all, we loop through for I in range 10, we get 0, and 0 is multiplied by 1. Actually, we can even do it like this. Like this. So in this way, we go through the loop, get our 0, we get 1, we multiply 0 by 1 and get 0. Next, we have 2, and we multiply 2 by 1, which gives us our 2. Well, let's say outputs 4. We see that 1 is multiplied by 4, and we get our 4. So a coroutine is a generator that accepts our value. Generators are perfect for reading a large number of big files. That is, we can sequentially receive our lines and then work with them, perform certain actions, since they output data one fragment at a time. They can also lead to cleaner code by breaking the iteration process into smaller components. In this way, we can more precisely separate our components by logic and structure our code more elegantly. And don't forget to subscribe, tell your friends, and give a like.